Hello and welcome back to this channel. Dear students, this session is quick revision of MOSFET and its analysis. That is, it is the quick revision of unit number 1 for the subject electronic circuits. I have already created the videos of subject electrical circuits for units 1 and 2, as well as I have already created video for quick revision of the subject electrical circuits. So please do watch that video. You can get those videos from the playlist. So let us start the session. ये जो क्विक रिवीजन का वीडियो है, in this video I will explain you some important concepts that are required as far as this INSEM exam is concerned. So let us start with the functioning or working of a MOSFET. This diagram is for N-channel MOSFET. MOSFET is metal oxide semiconductor field effect transistor. There are two types of MOSFET. One is P-type, another is N-type. Presently I am talking about N-type of MOSFET. याद कैसे रखना है, ये जो सबस्ट्रेट है, सबस्ट्रेट मीन्स बेस मटेरियल, ये वाला, this substrate is of P-type, whereas two regions are grown on this substrate, two N types of regions are grown. ऐसे याद रखना है. P type का substrate है, मतलब इसमें number of holes will be more compared to number of electrons. So I have shown more number of positive signs compared to number of negative signs. Negative signs means electron, positive signs means holes. अब देखो यहाँ पे there are three main terminals in case of MOSFET. One is drain, another is gate, and third is source. Usually the source terminal is grounded and this terminal is abbreviated as SS, that is substrate terminal. Many times ये substrate भी ground को connect करते हैं. VGS is the voltage applied between gate and source terminal. Gate terminal जो है उसको voltage apply करके you can control the things, you can control the current. So between gate and source the voltage applied is VGS. बहुत सिंपल है. GS मतलब गेट टू सोर्स, इसके बीच में जो वोल्टेज अप्लाई किया दैट इज VGS. ये टर्म पॉजिटिव है, सो पॉजिटिव वोल्टेज इज अप्लाइड टू द गेट टर्मिनल. दिस इज द ड्रेन टर्मिनल. बिटवीन ड्रेन एंड सोर्स, ये लोअर टर्मिनल, ये सोर्स का कनेक्शन है. बिटवीन ड्रेन एंड सोर्स द वोल्टेज VDS इज कनेक्टेड. नाउ as you go on increasing VGS, एक बेसिक कंसेप्ट याद रखना है. लाइक सिमिलर टू द ऑपरेशन ऑफ अ डायोड, there is some threshold level. मतलब if VGS is less than the threshold voltage VTH, then the MOSFET will be in cutoff condition. It will not operate. So if you are applying certain positive voltage and if you go on increasing this positive voltage above VTH, so as this positive voltage goes on increasing, remember that already हम लोगों ने ये VDS पॉजिटिव यहाँ पे अप्लाई किया है. मतलब this VDS is already positive and we are changing, we are increasing VGS. जैसे मैंने बताया, when VGS crosses the level VTH, VTH को बोलते हैं threshold level, then the conduction starts. So what happens actually, this positive supply is applied to the gate terminal. तो P टाइप के सबस्ट्रेट में जितने भी पॉजिटिव है, मतलब जितने भी पॉजिटिव चार्जेस है, दैट मींस द नंबर ऑफ होल्स विल गेट रिपील्ड फ्रॉम द स्ट्रक्चर, क्योंकि ये भी पॉजिटिव एंड दिस होल्स आर आल्सो पॉजिटिव. वेयरएज it is a P-type substrate, so minority carriers are electrons, means negative. So these electrons will try to get attract towards the gate terminal. जैसे जैसे VGS आप increase करोगे, more number of electrons will be attracted towards gate terminal. ये जो एक layer draw किया है, this is basically SiO2 layer, silicon dioxide layer. Because of this, जैसे as the number of electrons which are trying to attract towards the gate terminal goes on increasing, one channel will be formed. इसको ये वर्ड याद रखना है, दिस इज कॉल्ड इंड्यूस्ड चैनल. नाउ ड्यू टू फॉर्मेशन ऑफ इंड्यूस्ड चैनल द ड्रेन करंट can flow through this induced channel. This is the way how the MOSFET starts conducting. एग्जाम पॉइंट ऑफ व्यू से आप एक क्वेश्चन किस टाइप का एक्सपेक्ट कर सकते हो. एक्सप्लेन द वर्किंग ऑफ एन टाइप ऑफ मॉसफेट, ड्रॉ इट्स आउटपुट कैरेक्टरिस्टिक्स और ड्रॉ इट्स ट्रांसफर कैरेक्टरिस्टिक्स. So this is the conduction of MOSFET. Now consider one more case. Suppose I will keep VGS constant. I will keep this value constant and I will go on increasing VDS. तो एक स्टेज आएगा जहां पे जैसे जैसे आप ये इंक्रीज करते जाओगे, ये तो फिक्स रखा है, दिस इज कांस्टेंट, तो गेट टर्मिनल का जो वोल्टेज है ये ऑलरेडी पॉजिटिव और ये भी पॉजिटिव है, यहां से हमने ड्रेन टर्मिनल को पॉजिटिव वोल्टेज अप्लाई किया। एज यू गो ऑन इंक्रीजिंग दिस वोल्टेज at particular value, this positive voltage at the gate will be less, or it will start becoming lesser and lesser compared to this positive voltage, क्योंकि हम लोग ये increase कर रहे हैं, because of which the number of electrons which are trying to move towards the gate terminal will start decreasing। तो एक इस टाइप का स्ट्रक्चर आ जाएगा, मतलब the channel width becomes narrow, this is called pinch off region, and it will cause the MOSFET into, or it will move the MOSFET into the saturation region. This is called the saturation region. Now about the graphs, this is the graph of ID. ID is drain current which is measured in milliamperes versus VGS. VGS is gate to source voltage. जैसे मैंने बताया, जीरो से हम लोग VGS स्टार्ट करेंगे इंक्रीज करना, but if it is less than VTH, output will be 0. This is called cutoff condition, and as VGS becomes more than VTH, the conduction starts. So that means as VGS increases, ID increases. ये ग्राफ याद रखना है, ग्राफ से ही आप लिख सकते हो। This is called the transfer characteristics. सेकेंड कैरेक्टरिस्टिक, इट इज ग्राफ ऑफ ID versus VGS। अब देखो अलग अलग VGS के वैल्यूज लिए, सपोज VGS1, VGS2 एंड VGS3 एंड सो ऑन, मतलब इस लाइन पे हम लोग ये इंडिकेट कर रहे हैं कि VGS गोज ऑन इंक्रीजिंग। On this axis I am plotting VGS, that is voltage, on this axis ID, that is drain current, naturally it is in milliampere, so the graph will be like this। मतलब अलग अलग VGS के वैल्यूज के लिए हम लोगों को अलग अलग ग्राफ आएंगे। ये जो एक्सपोनेंशियल टाइप का कर्व है, इनिशियली द वैल्यू ऑफ IDS goes on increasing as VGS increases, this is called NS, मतलब नॉन सैचुरेटेड रीजन। Whereas जैसे मैंने बताया एक पर्टिकुलर स्टेज पे, जैसे ये VDS हम लोग इंक्रीज कर रहे हैं, तो इसका यहाँ का वोल्टेज, जो गेट का वोल्टेज पॉजिटिव वोल्टेज है, that will become less positive compared to voltage VDS, and pinch off occurs, that is called saturation condition। तो saturation मतलब ऐसे याद रखना है, the values remains constant, मतलब even if you go on increasing VGS, ID will not increase, it remains constant, and the width of channel get reduced। अभी जो हम लोगों ने डिस्कस किया, that was N channel E MOSFET. E means enhancement type of MOSFET. Now, if the question is related to P channel E MOSFET, याद कैसे रखना है? You don't have to prepare it separately. देखो, N channel में हम लोगों ने लर्न किया P टाइप का सबस्ट्रेट होता है, इससे एग्जैक्ट अपोजिट इसमें N टाइप का सबस्ट्रेट होता है। सो नेचुरली सबस्ट्रेट is of N type, that means number of electrons are more compared to number of holes, and major change यहाँ पे हम लोग को निगेटिव वोल्टेज अप्लाई करना है गेट टर्मिनल को। N E MOSFET में हम लोग पॉजिटिव वोल्टेज अप्लाई कर रहे थे, एंड अनदर चेंज इज सोर्स इज कनेक्टेड टू पॉजिटिव टर्मिनल, पहले के केस में सोर्स वाज कनेक्टेड टू ग्राउंड। सो remaining explanation will be as it is, means in case of N channel E MOSFET we discussed that the electrons were getting attracted towards gate terminal, इसमें exact opposite हो जाएगा, gate negative है, so holes which are minority carriers in N substrate will get attracted towards the gate terminal। Now about the characteristics, output characteristics, this is graph of ID versus minus VGS। ये जो वोल्टेज है बिटवीन गेट एंड सोर्स, दिस वोल्टेज, दिस इज नेगेटिव वोल्टेज, सो ग्राफ इज इन दिस क्वाड्रेंट। लॉजिक रिमेन्स सेम, whenever the voltage becomes greater than VTH, then conduction starts। this graph is same like the previous graph, सिर्फ चेंज, मेजर चेंज याद रखना है। पहले वाले ग्राफ में हम लोगों ने यहाँ पे VGS लिखा था, नाउ instead of VGS it will be VSD, source to drain voltage, and remaining things are as it is, means the nature of graph will be like this only। so this region is non-saturation region, this is saturation region। now about the symbols, पूरे चैप्टर में हम लोग ये सिंबल्स यूज करने वाले हैं। दिस इज द सिंबल फॉर एन चैनल मॉस्फेट, और सिंप्लीफाइड सिंबल इज दिस वन, कोई भी सिंबल चलेगा। याद कैसे रखना है? एरो, ये जो एरो है दिस इज आउटवर्ड फॉर एन चैनल ई मॉस्फेट, वेयरएज फॉर पी चैनल ई मॉस्फेट दिस इज इनवर्ड। देखो हर एक टॉपिक के लिए मैंने अलग से डिटेल में वीडियो बने हैं, ये सिर्फ क्विक रिवीजन का वीडियो है. सो आई एम जस्ट आई वांट टू ब्रश अप द थिंग्स एज फार एज यूनिट नंबर 1 इज कंसर्न्ड. Next part is MOSFET parameters. You may expect the question like define the MOSFET parameters, dynamic resistance, transconductance and conduction parameter. The value of dynamic resistance. अब देखो definitions mug up नहीं करना है. I will tell you simple trick. सिर्फ ये फॉर्मूला याद रखना है. ये फॉर्मूला जैसे ये R0 का फॉर्मूला, दिस इज कॉल्ड डायनेमिक रेजिस्टेंस. वी नो दैट डायनेमिक मीन्स इट्स चेंजिंग. ये भी फॉर्मूला कैसे याद रखना है? We know the basic Ohm's law. V is equals to IR. I is current, R is resistance, V is voltage. From this, I can write R is equals to V upon I. So basically, it is ratio of voltage to the current. वही लिखा है, सिर्फ नोटेशंस अलग है. डेल्टा मतलब चेंज, VDS मतलब ड्रेन टू सोर्स वोल्टेज अपॉन डेल्टा ID. ID is the drain current, delta is the change. For ये vertical line, what it indicates, how to read such terms. Vertical line is drawn, that means it is read like this: ratio VDS delta VDS to delta ID at VGS is equals to constant. Means for constant value of VGS, VGS is get to source voltage. So if you just remember this formula, you can write the definition on your own. How to write it? The dynamic resistance is the ratio of change in drain to source voltage to the change in drain current for or at constant value of gate to source voltage. Next definition on the same lines, transconductance. Transconductance is denoted by GM. ये इससे उल्टा लिखना है, मतलब डेल्टा ID अपॉन डेल्टा VGS. सिर्फ याद रखना है यहाँ DS है, यहाँ VGS है. For constant value of VDS. Again on the same lines, it is ratio of change in drain current to the change in gate to source voltage for constant VDS, that is for constant drain to source voltage. Next is the conduction parameter. अब देखो इसका आप significance भी लिख सकते हो. As the name indicates, conduction parameter means it is responsible for conduction of current. So you can well change the current capability of MOSFET by using this parameter. ये formula आप लोगों को याद रखना है. Kn stands for conduction parameter for N type E MOSFET and Kp for P type E MOSFET. Formula same है, सिर्फ notations अलग है. यहाँ μn है, यहाँ μp है. W is the width of channel. μn is mobility of electrons. COX is the capacitance of oxide layer. 2 is constant. L is the length of conduction layer. Same way W μp, this is mobility of holes. COX upon 2L. So from this we can easily say this conduction parameter is directly proportional to width. मतलब width vary करके हम लोग conduction parameter, for example, if you increase W, value of Kn also increases and it will increase the current capability of MOSFET. Next, an important topic is non-ideal IV, that is current voltage characteristics. You may expect the definitions of some current voltage, non-ideal current voltage characteristics, or the question may be like this: explain various non-ideal current voltage characteristics of MOSFET. So first is finite output resistance. So this notation is R0, small r0. I have drawn the graph of ID, that is drain current versus VDS. We already discussed this graph earlier. अब जैसे देखो ये ग्राफ ऐसे है, मतलब यहाँ पे ओरिजिन है, यहाँ से ऐसे एक्सटेंड होता है. आफ्टर सम पॉइंट इन द सैचुरेशन रीजन इट रिमेन्स कांस्टेंट. बेसिकली this slope of this graph is ID versus VGS, मतलब करंट वर्सेस वोल्टेज का ग्राफ है ये. स्लोप ऑफ दिस ग्राफ इज 1 by R0 and R0 is called finite output resistance. Formula is 1 by R0 is 1 by lambda into IDQ. lambda is the parameter, न्यूमेरिकल सॉल्व करते वक्त हम लोग ये ज्यादा डिस्कस करेंगे, which is same as VA upon IDQ. What is this VA point? जैसे ग्राफ आइडियली यहाँ से ऐसे 0 से स्टार्ट होता है, बट इफ यू एक्सटेंड दिस ग्राफ towards the backward side, all these lines will meet at a common point, that is minus VA. So this point is VA, which is VA upon IDQ. Now next is channel length modulation. So for if I have written in short, if VDS is drain to source voltage, if VDS is greater than VDS saturation, मतलब जो saturation का वैल्यू है उससे भी हम लोग VDS बढ़ाएंगे, then this point A will try to move away from the drain terminal and it will reduce the effective length of channel. This effect is called channel length modulation. मतलब सिंपल याद रखना है, अगर सैचुरेशन वोल्टेज से भी हम लोग VDS बढ़ाएंगे तो लेंथ ऑफ चैनल विल बी रिड्यूस्ड बिकॉज पॉइंट A will move away from the drain terminal, and this effect is channel length modulation. Then next is sub threshold conduction. Conduction is related to value of current. This is graph of square root of ID. ID is drain current versus VGS, get to source voltage. हम लोगों को पता है ये ओरिजिन है. if VGS becomes greater than VTS, that is threshold voltage, then conduction starts. So ideally we are getting a linear graph like this, and from 0 to VTH you should get 0 output, but in practical cases the graph is like this, shown by the dotted line. This type of current practically flows even if VGS is less than VTH. So this is exponential current, which is called sub-threshold conduction. Now, fourth parameter is breakdown effect. There are two types of breakdowns. One is avalanche and another is punch-through breakdown. See, in case of N-type E MOSFET, we discussed that the substrate is of P-type and the source and drain terminals are connected to N-type dopant materials. So it will basically form PN junction. So drain to substrate junction is PN junction, and if large negative voltage is applied to this PN junction, then breakdown takes place, which is avalanche breakdown. Next is punch through breakdown. अब देखो हम लोगों ने ये लर्न किया कि चैनल होता है, then as you go on increasing the drain voltage and if you keep VGS constant, then less number of electrons will try to move towards the source terminal. So this effect is related to the phenomena of depletion region. Whenever depletion region means as you go on increasing the VDD value, then the depletion region enters into the source terminal or tries to enter into the source terminal. This effect is called as punch through breakdown effect. Two more parameters are remaining. First is temperature effect. I mean, this might be sixth parameter, which is non-ideal IV characteristics. So due to variation in the temperature, the change in value of VTS, that is threshold value, threshold level, gets changed. Then there is a change in resistance of MOSFET, and there is a change in value of K, that is change in value of Kn or Kp depending on the type of MOSFET. Then last parameter is last characteristics is effect of W by L ratio. W is width, L is length of the channel. So we have discussed this formula. Kn is W mu n COX upon 2L. Mu n, that means we are talking about N type channel, N channel E MOSFET. This value W is width, L is length of channel, 2 is constant. Mu n is mobility of electrons, COX is capacitance of oxide layer. These values mu n and COX are almost constant, so we can say that this parameter Kn is dependent or proportional to W by L ratio. Rather, it is directly proportional to the width of depletion region. और ये sentence याद रखना है. By changing the width of depletion region, you can change the conduction property of the MOSFET. Next part is DC analysis of a MOSFET. अब देखो, you may expect a numerical related to this. Numerical simple है, बिल्कुल skip मत कर लो. I have already created separate videos as far as numericals on first unit are concerned. ये न्यूमेरिकल सिर्फ आप लोग इतने फॉर्मूला का लिस्ट याद रखोगे, you will be in a position to solve the numericals. First is IDQ, ऐसे याद रखना है. ID is drain current, Q is related to Q point और saturation, ऐसे याद रख लो. So if the MOSFET is in saturation, calculate ID using this formula. This K is Kn for N type E MOSFET and Kp for P type E MOSFET. Values will be given in the question. VGS is get to source voltage, VTS is threshold voltage. So K inside the bracket VGS minus VTS square. Then calculate VDQ you by applying KVL. One more formula of ID is there. If MOSFET is not in the saturation mode, then you need to make use of this formula. देखो ये formula basic formula है. इसमें अगर हम लोग लैम्बडा का वैल्यू 0 पुट करेंगे, so this term will become 0, so 1 plus 0 becomes 1, and only this term remains, that is the value of IDQ. Next is R0, that is resistance. We have already discussed this parameter. It is 1 by lambda into ID. Now, how to draw the diagram? As far as the diagrams are concerned, DC equivalent circuit, which we call it as. So, to draw DC equivalent diagram, replace all capacitors by open circuit and replace all AC voltage sources by the short circuit. This OC means open circuit, SC means short circuit. So, without fail, do watch the video as far as these numericals are concerned. Next part is common source MOSFET amplifier. This is the diagram of common source MOSFET amplifier. Why it is called a common source? As the name indicates, the source terminal is common between इनपुट एंड आउटपुट. जैसे देखो ये सोर्स टर्मिनल इट इज ग्राउंडेड, आउटपुट हम लोग यहां से मेजर कर रहे हैं, मतलब यू कैन से आउटपुट इज मेजर्ड बिटवीन दिस पॉइंट्स. ये ग्राउंड है, मतलब मींस फ्रॉम दिस पॉइंट एंड सोर्स, एंड इनपुट इज अप्लाइड, वी इन इज अप्लाइड इनपुट. So input is applied between gate and source terminal. This voltage is naturally VGS, whereas this voltage is VDS. So source is common between input and output. So it is common source MOSFET amplifier. जो VGSQ है, this is the value which is responsible, or I mean this value is greater than the VTS threshold value. So it is responsible to drive the MOSFET in saturation mode, in saturation condition. In series with this, I have connected Vin. Vin is the small voltage which is to be amplified. तो हम लोग ऐसे बोल सकते हैं, ये जो small voltage है जिसका हमें amplification करना है, that is superimposed with VGSQ, and then it is applied to this MOSFET. So at the output, you are getting amplified output. अब ये AC इक्विवेलेंट डायग्राम है, ये आप लोगों को याद रखना है. Vin इज इनपुट वोल्टेज, VGS इज यहाँ पे गेट टर्मिनल है, VGS इज वोल्टेज बिटवीन गेट एंड सोर्स. देन GM इज ट्रांस कंडक्टेंस, VGS वी ऑलरेडी डिस्कस्ड. R0 इज स्मॉल सर्किट इक्विवेलेंट आउटपुट रेजिस्टेंस. RD is the drain resistance. ये resistance है connected to the drain terminal. I mean from VDD to the drain terminal. This resistance is RD. V0 is the output voltage. Now to draw the AC equivalent circuit, you need to follow only these two rules. Replace all capacitors by short circuit and set all DC voltages equal to 0. मतलब जितने भी कैपेसिटर्स है शॉर्ट सर्किट करना है, मतलब एक सिंपल वायर कनेक्ट करना है, और जितने भी DC वोल्टेजेस है वो 0 करने हैं. As far as the numerical part is concerned, if you remember this set of formula, you will be in a position to solve the numericals related to AC analysis. AC analysis का भी सेपरेट वीडियो है, प्लीज वॉच दैट वीडियो, क्योंकि ये सिर्फ क्विक रिविजन का वीडियो है. सो आई हैव गिवन यू द लिस्ट ऑफ फॉर्मूले. IDQ ये सैचुरेशन कंडीशन पे ड्रेन करंट का इक्वेशन है. K that is Kn or Kp, VGSQ minus VTH bracket square. GM trans conductance is 2K VGSQ minus VTH, and R0 is 1 by lambda 1 upon lambda into IDQ. अब देखो हम लोगों ने कॉमन सोर्स डिस्कस किया. लाइकवाइज देयर इज वन मोर कॉन्फ़िगरेशन which is generally used, that is common drain, CD, common drain configuration, which is also called source follower. जैसे source common लेते हैं input और output के बीच में, likewise drain terminal is taken common and it is called source follower circuit. Next is frequency response of an amplifier. This is the graph of output voltage or gain on y-axis versus frequency on x-axis. Ideal graph should be like this. मतलब ये dotted line से जो बना है, this should be the ideal graph. इसमें 3 regions है. LF, that is low frequency region. In this region, the value of gain increases as frequency increases. Mid frequency region, in this case, output voltage or gain remains constant. High frequency, HF means high frequency region, in which the value of gain or output voltage decreases with increase in frequency. अब यहाँ पे ये जो MF का रेंज है, मतलब मिडल फ्रीक्वेंसी का जो रेंज है, इसका जो वैल्यू है, दैट इज द मैक्सिमम वैल्यू ऑफ गेन, दैट इज डिनोटेड बाय AV, वोल्टेज गेन. इसका अगर हम 0.707 लेंगे जिसको टेक्निकली बोलते हैं 3 dB पॉइंट, सो इफ यू टेक 0.707 टाइम्स AB वैल्यू, तो 2 पॉइंट्स मार्क किया मैंने इस ग्राफ पे, दिस पॉइंट एंड दिस पॉइंट. If you take the readings related to this point, these points are called as hub power points. So related frequencies are FL and FH. So if I want to write equation of bandwidth, then it is higher frequency FH minus lower frequency FL. Now these points are important. In the low frequency region, in LF region, low frequency region, gain reduces. This downward arrow indicates it is reducing, quantity is reducing. Gain reduces due to coupling and bypass capacitor. हम लोग coupling और bypass capacitor यूज कर रहे हैं, जिसकी वजह से gain reduce होता है in the low frequency region. Whereas in the high frequency region, the gain reduces due to internal capacitance and stray capacitance. So, dear students, that's it for the quick revision of MOSFET analysis. That is unit number 1. So, thanks a lot for watching this video.